start by cleaning our vessels. We need to clean both our pipette and graduated cylinder with water and with our solution. We must fill it with water and flush 3 times, then with our solution and flush 3 times. A stock solution is a concentrated solution that will be diluted to some lower concentration for actual use.
We will be using the C1 times V1 equals C2 times V2 equation during our 3 trials today to find the concentration of a diluted solution. The C1 represents the concentration of the original stock solution, 20%, and V1 is what we must solve for. It represents the volume of stock solution we must begin with to reach our desired percent concentration for each dilution, whereas C2 and V2 represent the concentration in the volume of the diluted solution.
For trial 1, we begin with 18.75 milliliters of stock solution in order to reach a concentration of 15%. We use the graduated pipette to draw up this amount of 20% stock solution from the left beaker and add it into the 25 milliliter flask. We read the graduations on this pipette from the meniscus.
The meniscus is the bowl-shaped dip in the liquid we are measuring. It is formed because the surface tension of the liquid causes the edges of the liquid to cling to the sides of the vessel. The center of the liquid doesn't have as much surface tension though, so it sags down, thus forming the meniscus.
We then use the 1 milliliter plastic pipette to draw up our water from the right beaker to dilute the stock solution to the desired percent concentration. We fill up the flask to the 25 milliliter line with the water dilute. We will repeat this procedure for all 3 trials. Isabella moves on to trial 2, which requires 12.5 milliliters of stock solution to reach a concentration of 10%. Katie completes the last trial that desires a 5% concentration by using 6.25 milliliters of the stock solution.
To find the mass of our solution, we must measure the mass of the flask by itself and then measure the weight of the flask with that diluted solution in it.
To find the density of each dilution, we had to divide the dilution mass by its volume. The dilution mass was found by subtracting the initial volume of an empty flask by the final volume of the flask containing the dilution. We then divided the dilution mass by its volume, which remained at a constant 25 milliliters, to find the density of the dilution.
We then plugged in our 3 concentrations and their densities into Excel, and we created a concentration curve of our sugar solution that had an equation of y equals 0.0032x and plus 0.993.